Hello, welcome once again in this video lecture series for analog circuits and design. See what we had in last lecture. Let's check. We had this. We had discussion about equivalent model, hybrid equivalent model of a transistor. Now here from this point onwards, now let's continue with hybrid equivalent module. Alright. So let me draw a line. What's the date? It's okay. Let us think about the transistor, that what already we have studied. If I have a transistor in its hybrid equivalent circuit, then there must be an input impedance. What we call this? It is HIE. Okay, don't even think about whether it is common emitter, common base or common collector. Don't think. So let's write only HI. So this is HI for me, is it? And now there is input voltage source. Now this input voltage source, what it is HR. See, I'm not writing HRE, I'm just writing HR. HR multiplied by V2, that is output voltage. See, if it is common emitter, then what I supposed to write? It must be HRE multiplied by V2. What is that V2? V2 is output voltage. Output voltage in case of common emitter configuration is VCE. So I supposed to write VCE, that is HRE multiplied by VCE. But see, I am just drawing a transistor's equivalent model, so I am writing HI and VR, not a specific common base or common collector or common emitter as such. Right. Okay, in the output stream, what I have a current source and one impedance is in parallel with it. What is this impedance? It is 1 divided by HO, and this is a current source. What is that current source? It is HF multiplied by input current II. Right. So this is what a transistor I have, and hybrid equivalent model of a transistor. Let me write it here. This is hybrid equivalent model. Equivalent model of transistor. This is hybrid equivalent model for a transistor. Now I want to derive amplifier's parameter. See, I want to derive amplifier parameter from this circuit. Actually, it is an equivalent circuit. So I want to derive amplifier's parameter from this equivalent circuit. It means now what I am going to do, I will treat this module, I will treat this transistor module as an amplifier. So if I want to treat this transistor module as an amplifier, I have to apply some input signal, I have to take output across the particular load, is it? Then only I can derive the amplifier's parameter, is it? So first, before starting, let us know what is that amplifier parameter that I am talking about. So this is transistor equivalent hybrid model. Yes, this is known, this is okay, and from that I am deriving amplifier's parameter. So amplifier's parameter, it means what I am talking about? I am talking about output impedance, input impedance, current gain and voltage gain. Those are four basic parameters for any transistorized amplifier circuit, or what I can say is for any amplifier. Right. For any amplifier, those four important parameters are always considered. So now what is my job? My job is to derive this input impedance from this circuit, to derive equation for output impedance from this circuit, to derive current gain as well as voltage gain from this transistorized equivalent circuit or equivalent H module of a transistor, is it? So if I want to derive these amplifier parameters, first thing what I need to do is I have to apply some input signal. So here I will apply input voltage. Look at this. This is what input voltage that I am applying. So if I am applying input voltage, then I have to draw a small series resistor RS. Yes, that is must. Right. What else I have to put in the circuit? Another thing is load resistor. Even it is an optional thing, then also I am connecting it. Why? Because I want to treat this equivalent module of a transistor as an amplifier. So that's why I am applying input signal and I am taking output signal across the load. So across the load, so that's why I have connected RL. So this is RL and this is input voltage. Let me call it as Vs. So input signal I have applied. I am taking output signal across load resistor RL. So now let us start analysis. Let us start analysis means let us start deriving RO, RI, AI and AV from this circuit. Is it? So as if one thing I know that this is input part. Is it not? As this is input part, so it means, okay, let me change the pen. It means I can say if I see impedance from this point, that impedance will be input impedance, that is Ri. You try to understand, I am talking about impedances. What is that? This is output impedance, this is input impedance, this is current gain, and this is voltage gain. Those four parameters are there. Now come to the circuit again. See, if I am checking circuit from the input side, then it is input impedance. Is it? So now as if now see, apart from this input impedance, if I say this is what voltage at the input side, then I will give a notation as V1. Is it? V1 is the input voltage. Is it? The voltage which is exactly present at the base of a transistor. That is what input side. Is it? See, I am not talking about this voltage. This is a source voltage. See, I will write here. This is a source voltage that I have applied externally, maybe with the function generator. Is it? I have taken a function generator and then a function generator's input voltage that I am treating as a source voltage. Is it? And the voltage which is available exactly at the base of that amplifier, or maybe the base of the transistor, sorry, is treated as an input voltage. So I am writing V1. So V1 is different from Vs. Is it? So as if we are marking V1, let us mark V2 also. V2 means obviously it is an output voltage. So if it is an output voltage, it means it is the voltage present across the load resistor. So this is what my V2. Is it? So voltage is present across the load resistor. And now look at this. Some current, let me change the pen. A current is flowing through the collector. Current is flowing through the load. See, those currents, those two currents represent the output current. But see, the directions are different. Why the directions are different? Because we are in equivalent circuit. Is it? If it is an actual amplifier circuit, obviously the direction must be same. But here we are in equivalent circuit. So this represents output current I2 and this represents load current IL, and both are same in magnitude. It means I can write I2 is equals to IL, same in magnitude but opposite in phase. It means what I need to write? I need to write I2 is equals to minus IL, or I clearly write IL is equals to minus I2. Is it? You can write, okay, let me rub it and let me write it as minus IL. Either I2 is equals to minus IL or IL is equals to minus IU. That is what I can say. I can write here, they are same in magnitude. but opposite in phase. Opposite in phase. That's what the actual meaning. So what is the conclusion? So two output currents are there. One is flowing through the load resistor, another is flowing through the collector. So I2 is nothing but IL, but the phase is different. That's what it is it? See, I'm just marking the currents which are flowing through our circuit. Okay, output from, apart from this output side, come to the input side. Do we have any current at the input side? Yes, we have current at the input side, and I'm writing it as I1, I2 and I1. Instead of writing II, let me write it as I1. So now I1 is the input current, I2 is the output current, V1 is the input voltage, V2 is the output voltage, Ri is the input impedance, and if you want to, then let me write this Ro as an output impedance also. So now the circuit is symmetric now. See, input impedance, input current, input voltage, everything I have shown here. So now let us start with actual analysis. Right. So let me change the pen here. Let me start with actual analysis. Now, analyzing this circuit, let me consider the first parameter as current gain. Let me write it current gain. So current gain will be the first parameter that we are going to derive from this above circuit diagram. What is that above circuit diagram? It is an transistor equivalent hybrid module. So let us start with what is gain. Basically, gain means output divided by input. Yes, it is well known. So as if gain is output divided by input, what is current gain? It is an obvious that current gain is output current divided by input current. So let me write it as it is. By the definition, what is current gain? Current gain is equals to, see, I am writing AI. I stands for current, A stands for gain. So AI is the current gain. So let me write here also in the bracket, AI is equals to output current. What is output current? IL is the output current. What is the input current? Input current is I1. So now I know that IL is nothing but minus I2. So can I write it is same as minus I2 divided by I1? Yes, it is possible. At the first side, I told you that I am taking output across the load resistor. Obviously, I have to consider IL as a load current. So I have considered it. But what is equivalent to IL? It is minus I2, because IL is in same magnitude with I2 but is in opposite phase with I2. So I am writing minus I2 divided by I1. Now, look at the circuit. This circuit. Can I copy this circuit? Let me check whether it is possible. Yes, it is possible. And let me copy the complete circuit so that it will be easy for us to understand the same circuit at the same instant. Okay, let me paste it. Now observe this circuit. What is my aim? My aim is to get current gain. Now look at this. For this circuitry, what is I2? What is I2? Let me tell you properly what is I2. I2 is equals to what? I2 means this current. Let me take marker. I2 is this current. Look at this. This is what the current which is flowing. That's what I'm talking about. It is I2. Now I2 is equals to what? It is this HF multiply by I1. That's what the only value? Yes, it is. No, that's not the only value. I2 is divided again into two parts. Look at this. One part is flowing as HFI1, another part is flowing as another current from 1 divided by HO impedance. So I2 is nothing but this impedance plus this impedance, is it not? So let me write value of I2, or equation for I2 is equals to HF multiply by I1 plus V2 divided by 1 divided by HOE. I hope you will understand that the current flowing through 1 divided by HO is how much? Current is equals to voltage divided by impedance. So what is the voltage across HO? It is V2. Look at this, V2 is nothing but voltage across HO and voltage across RL. So V2 is voltage across 1 divided by HO impedance, is it? So V2 is voltage across 1 divided by HO impedance divided by the value of impedance, that is 1 divided by HO. So what it represents? A current. So HF I1 plus this thing. Let me simplify this. So if I simplify this, what I am getting HF multiplied by I1 plus this HOE. Oh, it's not HOE, it's just HO. So it will be HO multiplied by V2, or what I can say, a V2 multiplied by HO. Call it as equation number 1. So this is what the first thing that I have derived. Is that? But see, value of V2, look at this. But the value of V2, what is value of V2? V2 is the output voltage. Is it not? V2 is the output voltage, that is V2 is equals to IL multiplied by RL. Is it not? So it means, can I write V2 is equals to minus I2 multiplied by RL? Yes, I can write this. So V2 is equals to what? V2 is equals to minus I2 divided multiplied by RL, because IL is equals to what? Minus I2. So now if this is the value of V2 I am getting, so can I put this value of V2, this value, just a sec. Okay. Sorry for the interruption. So this V2 we have derived. Now put this value of V2 in equation 1. It means where I need to put? I need to put this value here. Is it? So if I put the value of V2 in the equation of I2, then what I am getting about I2? So I2 will be HF I1, is it? HF I1 plus, now what is this V2? Look at this equation I am talking about, HF I1 plus, now V2 is equals to what? Minus I2 RL. So it means it should not be plus. Okay, in next step I will write it. It is minus I2 multiplied by RL multiplied by HO. Is it not? It is HO. See, I am just putting value of V2 in equation 1. Okay, those who don't understand, I will write a comment here. Put value of V2 in equation 1. This is what equation number 1 talking about. So finally I am getting value of I2 is equals to, let me simplify this again. So I2 is equals to, it is HF multiplied by I1 minus HO I2 RL. That is what the value of I2 finally I am getting. Right? But see, value of I2 is not the final aim. What I need to derive? I need to derive equation for I2 divided by I1. Is it? That's what my interest is. So here, so HF multiplied by I1 will be I2 plus HO I2 multiplied by RL. So look at this, I am just simplifying it. I will get I2 is equals to 1 plus HO multiplied by RL. This is what HF multiplied by I1. So from this, can I write I2 divided by I1 equation? I2 divided by I1 will be then I2 divided by I1. So this thing will go here. So HF divided by, so finally I am getting HF divided by 1 plus HO multiplied by RL. So this is what my equation for I2 divided by I1. Is it? So but what is that I2 divided by I1? Look at this, AI. AI is equals to what? I'll write AI is equals to, sorry, minus I2 divided by I1. So it means, can I write AI is equals to minus of the above equation, HF divided by 1 plus HO multiplied by RL. So this is what the first parameter we have derived from hybrid module of a transistor. What is that? AI is equals to minus HF divided by 1 plus HO RL. Is it? See, whatever analysis we have done, all the analysis is independent of the voltage source Vs. Is it not? So let me write here. This is what? This is independent of Vs. See, we have not considered Vs at all. But what if we consider Vs then? Right? By considering Vs, let me write it, by considering Vs, I have to write current gain as AIS instead of AI. See, just S I have added. What is that as? S means current gain with reference to the voltage source. Or what I can say is current gain with reference to the source. So now let's consider that I have connected voltage source to the amplifier. Okay. Let me derive that here itself. If we consider voltage source in the equivalent circuit, then what will happen? Now here if I consider voltage source in the amplifier, it means the voltage source, look at this, the voltage source will drive the amplifier. Is it not? As input voltage source increases, the output voltage also increases. Input voltage source decreases, that is source voltage decreases, output voltage also decreases. It means source voltage will drive the amplifier. Now in that case, if I want to calculate what is the current gain, then what is the provision? See, there is a provision. So let me draw the equivalent circuit first with reference to the source voltage. So here I have a source voltage. Look at this, I will call this as source voltage Vs. This is a small resistance Rs, and this is something that I will call it as an Rn. What is that Rn? Rn is the input impedance of an amplifier. We'll call this as Rs, and this is Rin. And what is this? This is V1, input voltage to the amplifier. Is it the same that already we have drawn here? Look at this. This is something Vi, that is input voltage, and this is Ri, that is input impedance. Is it? So the notation is Ri. So that's why follow the same Ri. Instead of writing Rin, just write Ri. Now I am interested in voltage gain. But how can I calculate voltage gain if I have a voltage source? Is it? So what is the aim? Aim is to get current gain. Sorry, did I say voltage? No, it's a current gain. The aim is to get current gain. Now I want current gain, but what I have voltage source. So let us convert that voltage source into current source. How? Okay, let me draw it here itself. So this is what a voltage source converted into current source. This is what Vs, let me call it as an Is, and then the resistances or the series resistance which is there in series with voltage source, now it will come in parallel with the current source. So now this is what my Rs. The input impedance of an amplifier, obviously it will remain as it is. Okay, it should not be R in, it should be only Ri. So let me draw it here. So this is input impedance Ri, and what is that? It is input voltage V1. Now try to understand why I am doing this. Because we are interested in current gain. We are interested in current gain with reference to the voltage source. But see, in an equivalent circuit of the input part, what we have is a voltage source. I don't want this. I want current source. So I have converted that voltage source into the current source, and that's what finally I am getting at the input side. Is it? Now, let me write equation for current gain, that is A. Is it? Now what is current gain? It is always equals to output current divided by input current. Now in my case, what is input current? It is Is. Now it is not I1. Why it is not I1? Because now I have considered voltage source, external source that I have connected to the base of the transistor. So input current is nothing but the current given by that source. So I am writing I2 divided by Is. Is it? So now that I2 is nothing but minus I2. Because ideally I have to consider, or if you don't understand this, let me write this A is equals to what? It is IL divided by Is. This IL divided by Is means it is minus I2 divided by Is. So it is what? Minus I2 divided by Is. So this minus I2 divided by Is, can I simplify this? Like I'll write minus of I2 divided by I1 multiplied by I1 divided by Is. It is possible, it's just mathematics. Now see, I1 will get cancelled. Eventually what I am getting, minus I2 divided by Is. That's what, which is A. Now this A will become AIS. Why? Because of voltage source Vs I have considered. So now this A will become AIS, and what is the value of AIS then? The value of AIS is equals to minus I2 divided by I1 multiplied by I1 divided by Is. Even at the start, if you write AIS, then also it is okay, no problem at all. Is it? But see, we have used the new term, that's why I started with the old one, that is A is equals to IL by Is. If it is a gain with reference to the voltage source, I have to change the notation from A to AIS. Okay. Now what is this minus I2 divided by I1? Does it simply shows AI? That is current gain without considering voltage source. So it is AI is multiplied by I1 divided by Is. This is what my AIS is. Okay. But see, if okay, let me make a block for this. Yeah, this is a valid equation, no issue. But now further, if I want the value of current gain in terms of impedances, because see, the current gain we have represented here in the term of impedances. RL is there, HF is there, HO. Either impedance must be there or some H parameters must be there. Is that so? If I want AIS in terms of H parameters or in terms of resistances, that is impedances, then I have to modify the equation again. Why I am doing this? Because I don't want AIS in the form of I1 or IS. That's why I don't want this. What I want AIS in the form of H parameters or impedances. Why I want this? Because I don't want AIS in the form of current, that is I1 or maybe IS. So now by current division rule, look at this, by current division rule, let me write equation for I1. So by current division rule, what is I1? For this circuit I am talking about, I1 is equals to where is I1? I1 is nothing but input current. No, this is current. This shows I1. Is it? So what is that I1? I1 is equals to this RS divided by both resistances, that is RS plus RI multiply by this IS. So I hope you know current division rule. So from that I1, that is current flowing through input impedance. What is that I1? I1 is, let me write it here, current flowing through input impedance. Right. So what is the equation for I1? So I1 will be the opposite resistance divided by total resistance multiply by the value of complete current source, that is what? IS. Is it? Now this IS or value of I1 is there with us. Now what if I put this value of I1 in the equation of AIS? Right. Let me write, put this value of I1 in equation of AIS. Then equation of AIS becomes AI multiply by. Now what is I1? I1 is RS divided by RI plus RS. Why? Because this IS and this IS will cancel each other. So IS will get cancelled. So finally I am getting, this is what? Current gain. This is current gain. Let me write it here, current gain with reference to voltage source Vs. So here we are concluding, this is the current gain with reference to the voltage source Vs, and this is what your first parameter. See, first parameter is to derive only current gain, but as an additional part we derived current gain with reference to Vs also. Is it? So that's what the new thing that we have studied now for this lecture at least. So this is first parameter. Like this we have to derive remaining 4 parameters related to amplifier. Is it? So next parameter that we are going to derive is input impedance. So let us write equations for input impedance.